I'm Anil Kumar, and in this video, I'll discuss all about reciprocal functions. We'll take up reciprocal of linear and quadratic function, discuss some key features, graph, vertical asymptote, horizontal asymptote, x-intercept, y-intercept, domain range, and behavior, positive, negative interval, and increasing, decreasing interval. To give you an idea, let me just sketch some reciprocal functions here. I'll sketch one for linear function and three for reciprocal of quadratic functions. And then we'll discuss at length how to find all these characteristics of these reciprocal functions. So let us say a linear function is kind of like this. We could have a parabola kind of like this. We could even have a parabola, say like this, right? Or a parabola which does not have any x-intercept. Now, if I have to sketch reciprocal of these functions, then they will be kind of like this. Wherever there is an x-intercept, we'll actually have a vertical asymptote, right? So we'll have vertical asymptote at the x-intercepts. In this case, right there. No vertical asymptote here. The second feature which we'll concentrate is that whenever we are going to have, let's say, approaching positive infinity, in that case, the graph of reciprocal function will approach 0 from the positive side. If we are approaching negative infinity, then reciprocal will approach 0 from the negative side. So in this case, that is how you're going to approach. Now these are approaching positive infinity, so we'll approach 0 for the reciprocal function, right? So imagine that this is the reciprocal function, right? So 1 over f of x. And this is reciprocal of the function f of x, correct? Now in this particular case, since we are approaching negative infinity, the graph of reciprocal function will approach 0, but from the negative side, okay? Now, if we know the x-intercept, let us say the x-intercept here is half. In that case, the reciprocal of half is 2. So somewhere there we'll have the y-intercept, right? So reciprocal of half is 2, so it'll be kind of like this. So you could actually sketch the graph of the function kind of like this, where the point where both the functions intersect will be what? That is important to understand. The point where the function and its reciprocal intersect will be either -1 y value or +1, correct? That is important. So in this graph, if this is -1, then the reciprocal will actually intersect this point and the graph will be kind of like this. So now I'm drawing the graph of the reciprocal functions, right? These are the graphs for the reciprocal functions, and this point, invariant point, will be at -1, correct? In this case, let us say this value is 1. In that case, the reciprocal of 1 is also 1. So both the graphs will have this point as common. It's called invariant point, correct? So that is how you're going to get the graphs for reciprocal functions. Now, let me summarize here some learnings which we did while doing all this. So what we saw here is that if I have a function f of x, and if we have reciprocal of this function, that really means 1 over f of x, correct? So that becomes the reciprocal function. So if I have a point on reciprocal function which is +1, then reciprocal will be +1. If I have -1, it will be -1. If I have plus infinity, it will approach to 0, right? So that means if the function is approaching infinity, reciprocal will approach 0. If it is positive infinity, it is going to approach 0 from the positive side, right? Like here. If the function is approaching negative infinity, for example, this place, in that case, it is going to approach 0, but from the negative side, quadrant 3 or in quadrant 4, as you can see here. Perfect. Now, wherever we have x-intercepts, for example, these points, those will be seen as vertical asymptotes. Perfect. These two cases are actually horizontal asymptotes, right? So these are key features which you'll find, and if the function is increasing, then the reciprocal should be decreasing. Is it okay? And if this is decreasing, then reciprocal will be increasing. If the function is positive, reciprocal will be positive. If function is negative, reciprocal will be negative. So these are common features for any reciprocal function, correct? Now let's consider reciprocal of linear function in slightly more details. So let me sketch one here, and then we'll write its characteristics. So let us say that we have a reciprocal function, we have a linear function, kind of like this. If the y-intercept here is 2, and let us say the equation of this function is y equals to, let's say slope is x, right? So let's say slope is x, and y-intercept is 2. We could write this as x plus 2, right? So what we have here is a function f of x equals to x plus 2. So the reciprocal function, let me write r of x, will be 1 over x plus 2. Perfect. Now as you can see from here, we have x-intercept here, and this x at minus 2. So at this point, we'll have vertical asymptote for the reciprocal of linear function. Now if that value is 2, then somewhere we'll have 1 also, correct? So let us say that is the point where we have 1, this is the point where we have minus 1. Now these are invariant points common to both function and its reciprocal. Since the graph of the function is approaching 0 from the positive side, the graph of the reciprocal will approach infinity on the positive side, right? And here, since the graph is approaching infinity, reciprocal will approach 0 from the positive side. So I could draw this graph kind of 1 over x kind of a graph. Do you see that? So that is how we are going to get graph of the reciprocal function r of x. Now, can you tell me what this point should be? It has to be reciprocal of 2, that is half. Perfect. Now on this side also, I could draw like this, the graph of reciprocal function. So as you can see here, to sketch the graph of reciprocal function, what we do is we find invariant points. Invariant points are the points where the value of the function, that is where f of x is equals to plus or minus 1. Since reciprocal of plus or minus 1 is same, right? That's one thing. So that gives you invariant points. Second is we find x-intercepts. So x-intercept of f of x. So that changes to vertical asymptote. For reciprocal function, right? And then lastly, we have to see the shape of the curve. So shape of reciprocal function will be like 1 over x graph for a linear function. So shape is like this. The only thing is, it has been translated up or down or left or right, correct? So normally it is translated left or right. And always what you'll find here is a horizontal asymptote. HA is for horizontal asymptote, y equals to 0, right? Always that is key characteristics. Perfect. Now let me write down the characteristics of the linear function which we have drawn here. That you know, but characteristics of the reciprocal of this function, r of x, which you see here, right? So what we observe here is, let's write down the characteristics. So what we see here is that we have end behavior. When x approaches positive infinity, the function y approaches 0 from the positive side. When x approaches negative infinity, y approaches 0 from the negative side. Reason is that this line is in quadrant 3 and it moves to quadrant 1, correct? So end behavior is both the ends are approaching 0, horizontal asymptote is y equals to 0, right? Now from this graph you can see that it is always decreasing. So here we have decreasing in the interval from minus infinity to the point where we have vertical asymptote, which is at minus 2, and from minus 2 to positive infinity, correct? And the function is greater than 0, that is to say it is positive in the interval from minus 2 to infinity, and is less than 0 or negative in the interval minus infinity to 2. Perfect. So these are other characteristics which you can see from here. And of course, we have already said that we have vertical asymptote at x equals to minus 2. Horizontal asymptote is y equals to 0, correct? We do not have any x-intercept here in this particular case, but we have a y-intercept at y equals to half for this particular graph, correct? So with this, I hope you have learned how to sketch the reciprocal of a linear function, right? So a line could have been dropping down with a negative slope. Let me take that kind of a line also. Let's say like this. In that case, assuming that this point is, let's say 4, the reciprocal of 4 will be 1 by 4, correct? Here we have an x-intercept, so vertical asymptote at this point. Somewhere here we'll have one value also, so that becomes invariant point. Positive reciprocal is always positive, right? And there you go. Here we'll have somewhere minus 1, correct? This is 1. So at minus 1 will be an invariant point, and the graph will be kind of like this. So that is how very easily you can always sketch reciprocal of a linear function, correct? Now let me take reciprocal of quadratic function. Now in this particular case, we have three cases. Case 1, 2, and 3, depending on the number of zeros for the quadratic function. So let me sketch all the three cases clearly. I did it earlier also in the very beginning. So a quadratic function could be like this, with two zeros. It could be kind of like this with 1 0 or no zero at all, right? So in these three cases, when we have two zeros, at every zero we'll have a vertical asymptote. So in the first case, we have two vertical asymptotes. In the second case, we have just one vertical asymptote, and here we do not have any vertical asymptote. As far as the end behavior is concerned, both sides are facing up, approaching positive infinity. So it approaches 0, the reciprocal 0, from the positive side. Perfect. Now there has to be an invariant point. Somewhere the function will have value 1. So I could sketch this part like this. Now let's look into the bottom half. If I know that this value is, let us say, 2, reciprocal of, minus 2. Reciprocal of minus 2 is going to be minus half. Negative reciprocal is always negative. Somewhere we'll have negative 1 also. So that would be the invariant point. So the graph will be a smooth curve, kind of like this. So that is how the reciprocal of a quadratic function with 2 roots will be, right? So let's say these are the 2 roots for us. And let's say these roots are at, let's say, minus 3 plus 3, correct? So we'll have vertical asymptotes at x equals to minus 3 and x equals to plus 3. Perfect. Similarly, the second graph reciprocal can be drawn very easily by locating plus 1. So let's say this is plus 1. So the reciprocal graph will be like this. So it is approaching 0, the x-axis, when x approaches positive or negative infinity, and it approaches positive infinity when x approaches 0. Right? Now in this particular case, if I say that this value here is, let us say, 2, the reciprocal of 2 is going to be half. Let's call this as half. And the function will be kind of like this. So as the value increases, reciprocal value decreases. So this particular graph will not have any vertical asymptote. Do you see that? Now from these 3 examples, I'd like you to write down the end behavior of each. End behavior really means, let me write down for this function now. If x approaches negative infinity, then y approaches 0 from the positive side. If x approaches positive infinity, y approaches 0 from the positive side, correct? Now in this case, we do not have any x-intercepts. However, y-intercept is at y equals to half, right? It is increasing in the interval from minus infinity to 0, and it is decreasing from 0 to positive infinity, correct? And it is positive from negative infinity to positive infinity. Domain is x belongs to real numbers, and range is y belongs to real numbers. However, y is between half and 0. So we can say y is greater than, y is better to write lesser value first. Y is greater than 0 and less than equals to half. So that is how you could write domain and range for this particular. Now let me write down the characteristics for this function also. You can say when x approaches positive or negative infinity, y approaches 0 from the positive side. Vertical asymptote here is x equals to 0. Now there are no x and y intercepts, right? So no intercepts. Increasing interval. So it is increasing all throughout in the quadrant 2, right? So that is to say from minus infinity to 0, and is decreasing from 0 to positive infinity. It is positive or greater than 0 from negative infinity to 0 and from 0 to infinity. Now since 0 is not the domain, we should use these brackets here, right? The domain for this function is x belongs to real numbers. However, x is not equal to 0, and the range is y belongs to real numbers, and in case of y, it is always greater than 0, right? So y is greater than 0. Now let's look into the characteristics of this function. Now here, the end behavior, you can see when x approaches positive or negative infinity, y approaches 0 from the right side. We have 2 vertical asymptotes here. One is x equals to plus 3, the other one is minus 3, right? Now, we have x-intercept, y-intercept at minus half, at y equals to minus half. It is increasing from minus infinity to minus 3, right? And then from minus 3 to 0 in these two quadrants, and it is decreasing from 0 to 3 and from 3 to infinity, correct? So that becomes the characteristics of this function, and of course domain in this case is x belongs to real numbers, where x is not equal to plus minus 3, which are the vertical asymptotes, and the range in this case is y belongs to real numbers. Now this point is minus half, so y is less than equal to minus half, and also y is greater than 0. So that becomes the range for this particular function. So I hope with this you understand how to describe, sketch, and understand reciprocal of linear and quadratic functions. I'm Anil Kumar. Feel free to write your comments, share your views, and if you like and subscribe, that'll be good. Thank you and all the best.